This is Unit 4, Linear Equations and Linear Systems, and this is Lesson 12, Systems of Equations. This is Activity 2, Passing on the Trail. And in Activity 2, you have two students, Han and Jada, and they are starting at a parking lot, and they are hiking to a lake. So there's a parking lot, and they start from the parking lot, and they hike to the lake. And they start at different times. Han starts before Jada, and when Han gets to the lake, then Jada starts, and she starts on her hike from the parking lot to the lake. So Han's hiking along, he finally makes it to the lake, and then once he makes it to the lake and turns and heads back, so Han reaches the lake, and when he starts to turn back, Jada is 6/10 of a mile away. So she's already started hiking before he makes it to the lake. And when he makes it to the lake, she is 6/10 of a mile away. And she is hiking at a rate of 3 2/10 miles per hour towards the lake. Han's distance d from the parking lot can be expressed with this equation. So his distance from the parking lot is expressed as a negative 2 4/10 t plus 4 8/10, where t represents the time in hours since he left the lake. So now he's reached the lake, and the time starts when he starts to hike back from the lake. So at time 0, if t is 0 here, at time 0, he's at the lake and he starts to head back. So if t is 0, how far is he away from the parking lot? So the distance d is from the parking lot. At time 0, this becomes 0 right here, this term, negative 2 4/10 times 0. So his distance from the parking lot is 4 8/10. That means that the lake is 4 8/10 miles away from the parking lot. So he hikes his 4 8/10 miles. Jada starts out after him, and she's hiking at a rate of 3 2/10 miles per hour towards the lake. And it says, what's an equation for Jada's distance from the parking lot? So how far is she from the parking lot for each unit of time, for each hour? So Han is hiking at a negative rate. So it's a negative 2 4/10 miles per hour because he's heading back. So his distance from the parking lot, for each hour, he's getting closer and closer to the parking lot. So that's a less and less distance from the parking lot. So you subtract that amount from the 4 8/10, the distance to the lake. So he's getting closer to the parking lot. So d is decreasing. So for Jada, the distance is increasing. She's walking away from the parking lot. So what's her distance from the parking lot? She's getting farther and farther away. So at time 0, Han's at the lake. Jada is 6/10 of a mile from the parking lot. So d for Jada is equal to 3 2/10 miles per hour. That's her rate. She's walking at a rate of 3 2/10 miles per hour. So each hour she travels 3 2/10. So this is time. This is time in hours. But at time 0, this term right here is equal to 0. So her distance from the parking lot at time 0, when Han reaches the lake, is 0 6/10. So she's 6/10 of a mile from the parking lot at time 0. So her equation can be written as distance from the parking lot is 3 2/10 times t plus 0 6/10. Now notice if you use d in Han's equation, so d is 0, so this is going to become a positive 2 4/10 t. So what's time when the distance from the parking lot for Han is 0? Well, this is a positive 2 4/10 t because you move it over to this side of the equal sign, equals 4 8/10. Well, then t is equal to 4 8/10 divided by 2 4/10. So if you work through that algebra, you're going to get time is equal to 2 hours. So it takes Han 2 hours to walk from the lake to the parking lot. And that makes sense. In 1 hour, he's 2 4/10 miles closer. So that means that he's actually 2 4/10 miles away because that's half of 4 8/10. And in the second hour, he travels that last 2 4/10, and he makes it to the parking lot. Okay, you were supposed to use this graph. I had forgotten about that, so I made my own graph. And so here's Han's equation. The distance from the parking lot for each of them is, D is the distance from the parking lot for both Han and Jada. So D in Han's case is a negative 2 4/10 times T. So for each hour, he's 2 4/10 closer to the parking lot, and he's starting at 4 8/10 miles away from the parking lot. So D is distance from the parking lot times 0 is Han at the lake. And Jada, her distance from the parking lot is every hour she walks 3 2/10. So she gets 3 2/10 miles farther away from the parking lot. And you also have to add her starting point at time 0, which is 0 6/10. Han's starting point at 0 is 4 8/10 miles away from the parking lot. Jada is 0 6/10 miles away from the parking lot. So the y-axis is going to be distance from the parking lot. So remember the standard form of the equation, I'll write that in a moment, is y equals mx plus b. So distance, y is distance in miles from the parking lot, and the x-axis is time. So these are hours on the x-axis. So this is a half an hour, 1 hour, 1.5 hours, 2 hours, and this gets out to be 2 6/10 hours. 2, 4, 6. I'm sorry. 1, 2, 3, 4, 5, 6. This is 2 6/10 miles. All right. So Han starts at the lake at time 0. So he hasn't gone anywhere yet. This is time 0. He's at the lake, 4 8/10 miles from the parking lot. He starts walking towards the parking lot, and we know he's going to get there in 2 hours. So it's going to take him 2 hours. At 2 hours, he is 0 miles from the parking lot. He is at the parking lot. So his rate is 2 4/10 miles per hour, negative 2 4/10 miles per hour. So in 1 hour, so right here, 1 hour, he has traveled a negative 2 4/10. So 4 8/10 minus that 2 4/10 gets you down here to 2 4/10. So he is right here in 1 hour, and then 2 hours, another 2 4/10, and another hour, and he is at the parking lot. Jada, on the other hand, she starts out when Han is at the parking lot, at the lake, 4 8/10 miles from the parking lot. Jada is already 6/10 of a mile from the parking lot. She has started to walk towards the lake. Now her graph is going up because she's getting farther and farther away from the parking lot each hour. And she is traveling at a rate of 3 2/10 miles per hour. So in 1 hour, she's going to go up. She's going to go away from the parking lot 3 2/10 miles. So you have to add 3 2/10 to 6/10. That's 3 8/10. So you go up here, and this is the point that she's at in 1 hour, 3 8/10 miles from the parking lot. Remember, you have to add that 6/10 to the 3 2/10 because she's starting at 6/10 of a mile from the parking lot. All right, so Jada, to walk to the lake. The lake, remember, is 4 8/10 miles from the parking lot. So that, for Jada to cover that distance, how long is it going to take her to cover that distance of 4 8/10 miles? So up here, 4 8/10 miles. So that's 4 2/10. So you have to subtract the 6/10 of a mile. So now you're at 4 2/10. You have to subtract this 6/10 right here. That's 4 2/10 is equal to 3 2/10 times the amount of time. She walks at a rate of 3 2/10 miles per hour. So time then, that amount of time that's going to take her to travel to the lake is going to be more than an hour. So it's 4 2/10 divided by 3 2/10. That's an improper fraction that's equal to more than 1 hour. If the lake were exactly 3 2/10, or actually I should say 3 8/10, miles away, where she's already walked 0.6 of a mile, then this would be 3 2/10 right here divided by 3 2/10, and that time would equal 1 hour. It'd be right here. But she has to walk farther, so it's that 4 2/10, that total distance that she has to walk, but she's walking at a rate of 3 2/10 miles per hour, so it's going to take her more than an hour to get there. So it's 4 2/10 divided by 3 2/10, and you can factor each of those. 4 2/10 is 2 times 3, 6 times 7 is 42, so 6 times 7/10. So this is 2 times 3 times 7/10 is 4 2/10, and this is 4 times 8 is 32, so 4 times 8/10 is 3 2/10. So this is 2 times 2 times 8/10. And these 2's, you can factor those 2's out. So now you're left with 3/2 of 7/8. So the tenths actually factor out also, so you're left with 7/8. And if you multiply this out, this is 21/16. 21/16, and you divide the 16 divided by 2 is 8. 21 divided by 2 is 10.5. So there's a little bit of arithmetic here. You should practice going through it, practice working with the fractions, simplifying the fractions, and then turn this into a decimal value, because this is a weird fraction to work with. Turn it into a decimal value, and you get 1 3/10 hours, a little bit more than 1 3/10 hours actually. So this is 1 3/10 hours right here. This is 1/10, 2/10, 3/10. So she is 4 8/10 miles from the parking lot. In a moment, we're going to figure out at what time during their walk both Han and Jada pass each other on the trail. You can actually get that from this graph. It's the point at which they intersect right here. So Jada's walking away from the parking lot. Han is walking towards the parking lot. And at this time right here, this is 3/4 of an hour, 75 hundredths of an hour into their walk. They are both 3 miles from the parking lot. So they are both at the same spot. Now it's useful to reason through this amount of time rather than to use the algebra, because when we go to using the algebra, which means setting these two equations equal to each other, it's going to help you understand where these numbers are coming from, where the calculations are coming from, or what they mean as you solve the equation. So let's reason through this first. So the question is, how long does it take them to close this distance between them? This gap. So how long does it take to close that gap? And can we figure that out? Can we reason through what that is? And so that gap is 4 2/10 miles. So it's the 4 8/10 miles that Han is away from the parking lot, minus the 0.6 of a mile that Jada is away from the parking lot at time 0. So that calculation is right here. This is 4 8/10 minus that 0.6. So we'll get to that in a moment. But Han walks that distance at a rate of 2 4/10. So he closes this gap at a rate of 2 4/10 miles per hour. Jada closes the same gap at a rate of 3 2/10 miles per hour. So if you combine those two rates, that's 2 4/10 plus 3 2/10, that's right here. 3 2/10 plus this 2 4/10, they combine, they close that distance between them at a rate of 5 6/10 miles per hour. But they're not 5 6/10 miles away. If they were 5 6/10 miles away, it would take them an hour. So if you spread out these two triangles so they just barely touch, so this side right here touches this side, then they would meet at an hour. They would meet out here. But they meet before in less than an hour. So that's why these two triangles overlap. It doesn't take them an hour to meet on the trail. So they meet right here. It takes a fraction of that 5 6/10 miles. They meet in after they close the gap 4 2/10 miles. So it's a fraction of that 5 6/10 miles. So what is that fraction? So this is 5 6/10 miles per hour. So that would take them an hour, but it only takes them a fraction of that hour. So that's 44 2/10 out of 5 6/10. That's the same as 42 out of 56. So factor out the sevens. 6 times 7 is 42. 8 times 7 is 56. So you get 6/8. Factor out the 2. 2 times 3 is 6. 2 times 4 is 8. So factor out these 2's. And this shows you, just by reasoning, that they meet on the path in 3/4 of an hour, right here. So after 3/4 of an hour, both will be 3 miles from the parking lot. Han walking from the lake to the parking lot, and Jada walking from the parking lot to the lake. That is the only time in which they're the same distance from the parking lot at the same time. Now up here, go back to here just for a second. Up here, this is 4 miles from the parking lot. And this is where Han is, 4 miles from the parking lot. So it takes him this amount of time, whatever that is here. It looks like it's 3/10 of an hour. And at the same time, 4 miles from the parking lot, Jada takes a little bit over an hour. It looks like an hour and 1/10, an hour and a half of a tenth, basically, to get to 4 miles from the parking lot. So they're both 4 miles from the parking lot, but it takes them a different amount of time to be at that 4 miles from the parking lot. This is the only time in which they're the same distance from the parking lot, 3 miles, at the same time. So they are passing, they are meeting at that time. Three miles from the parking lot in 3/4 of an hour, or 75 hundredths of an hour. So we just reasoned through what time and what distance both Han and Jada pass each other. What time or what distance do they meet on their walk from the lake for Han and from the parking lot for Jada. But what if we figured this out algebraically? How would we do that? Well, we know that they meet after 3/4 of an hour. So they've each walked 3/4 of an hour, so 45 minutes, 75 hundredths of an hour, and they have walked so that both of them are 3 miles from the parking lot. Well, that distance is the same for both of them, and we just want to figure out algebraically what time this is. So if we use these equations up here, we know that the distance is the same. We actually haven't figured out yet algebraically that this is 3 miles, but the point is that you know that the distance is the same. So you can set these two equations equal to each other. So a -2 4/10 times whatever time this is, we know it's going to be 3/4 of an hour, but right now it's just t, plus 4 8/10 miles. That distance is the same for Jada, which is 3 2/10 times the amount of time. So this is her rate, 3 2/10 miles per hour, plus she already has walked for 6/10 of a mile. So this distance is the same for both of them. So you can set these two equations equal to each other to figure out what time it takes to get to this equal distance. We don't know at this point in time. We haven't figured out what that distance is. We did figure it out by reasoning, but algebraically we have not yet figured it out. We just know it's the same. All right, so to go through that calculation, you're going to do the same calculations we just did when we reasoned through it. It's the 4 8/10 minus 6/10. This 4 8/10 up here minus this 6/10 down here, and that's equal to the combined rate. The rate at which they are traveling towards each other is their combined rate. It's the 3 2/10 plus 2 4/10. So this is a -2 4/10 times t, so it becomes a positive 2 4/10 times t, and this is a positive 6/10 of a mile, so that becomes a negative 6/10 of a mile, or you just subtract it from 4 8/10, same thing. So you end up with this equation, And to solve that equation, you're saying that 4 2/10 is what fraction of 5 6/10? So it's 4 2/10 divided by 5 6/10. That fraction is the same as 42 over 56. If they were 5 6/10 miles apart, then this would be 5 6/10. And you would get a time of 1 hour. But it's less than an hour. It's less than 5 6/10 miles. It's 4 2/10 miles. So that fraction is 3/4 of an hour. So 42 divided by 56, can factor out the 7s, factor out the 2. That's the same as factoring out 14. 3 times 14 is 42. 4 times 14 is 56. So you end up with 3/4 of an hour, or 75/100ths of an hour, or 45 minutes. Now to figure out the distance after that time, you use either of these two equations, because now that distance we know. To figure out the distance, you use either of these two equations, and now the time we know, which is 3/4 of an hour. So just use for this time here 3/4. And if you look at it, it's saying 3/4 of this rate. It's 3/4 of 2 4/10. It's 2 4/10 miles an hour, but Han walks 3/4 of that. So what's 3/4 of 2 4/10? That's the same as 3/4 of 24. 3/4 of 24. Take 24 divided by 4, that's 6, and it's 3 of those 6s, 3/4. So 3 times 6 is 18. So that this becomes a negative 1 8/10. This is just a little calculation over here to figure out what the digits are, and that number is then a negative 1 8/10. So in 1 hour, in 3/4 of an hour, Han has walked 1 8/10 miles towards the parking lot away from the lake, and that puts him at 3 miles away from the parking lot. Now you could also use Jada's expression. That's 3 2/10 miles in an hour, but she only walked 3/4 of that. So it's 3/4 of 32, or 3/4 of 3 2/10. Well, 32 divided by 4 is 8, and it's 3 of those 8s. It's 3/4. So 3 times 8 is 24, or 2 4/10. So again, this is just a little calculation to get the digits, 24, or 2 4, but it's 2 4/10. Remember, she had already walked 6/10 of a mile. So you add the 2 4/10 that she walks in 3/4 of an hour to the 6/10 of the mile that she'd already walked, and that puts her at 3 miles from the parking lot. So they're both 3 miles from the parking lot. So this is using the algebra to get these coordinates: 75/100ths of an hour, 3/4 of an hour, and at 3/4 of an hour, they are both 3 miles from the parking lot. So Han, he walks from the lake towards the parking lot in 3/4 of an hour. So this 44 2/10 is 3/4 of 5 6/10. So in 3/4 of an hour, he is 3 miles from the parking lot. So he has walked 1 8/10 miles. So 4 8/10 miles minus 1 8/10 miles. So here's the 1 8/10 miles right here. So this would be 2 miles to the 5, but he only goes to the 4 8/10. That's 1 8/10 miles, and he's walked that in 3/4 of an hour. So he's 3 miles from the parking lot. Jada is walking from the parking lot to the lake. She's already walked 6/10 of a mile at time 0. So at time 0, when Han reaches the lake and he turns around and heads back, she has already walked 6/10 of a mile. So now in 3/4 of an hour, she walks another 2 4/10 miles, because that's 3/4 of 3 2/10. Her rate is 3 2/10 miles an hour. 3/4 of that is 2 4/10 miles. So now she is 2 4/10 miles from the parking lot, plus the 6/10 that she's already walked. So that places her 3 miles from the parking lot. So they're walking the same amount of time, 75/100ths of an hour, and they meet at the same distance from the parking lot, 3 miles. So what happens to Han and Jada's walking rates if they meet in an hour right here rather than 3/4 of an hour or 45 minutes right here? So let's change this to an hour and see how their rates have to adjust to meet in that hour. So here I moved it out an hour. So if I go back just for a moment, you can see what's happening. It's moving out to an hour. And so notice both of their rates have to change. And how do their rates change? So Jada's rate, she's going to walk 3 miles, or she's going to walk until she is 3 miles from the parking lot. And it's going to take her an hour. Before it took her 45 minutes or 3/4 of an hour. So now she's going to take a longer amount of time to reach that point where she's 3 hours from the parking lot. So notice that the slant of her graph is going to become less. It's going to be less slanted because she's walking at a slower rate. And so how much does her rate have to adjust? She already walked 6/10 of a mile, and now she has to walk another 2 4/10 miles to get to that 3 miles out. So she has to walk 2 4/10 miles in 1 hour. Well, that's her rate, 2 4/10 miles per hour. So she has to slow down. So this is slowing down from 3 2/10 miles per hour to 2 4/10 miles per hour. So notice she's taking a longer time. So this time is going from 3/4 of an hour to 1 hour to walk that same 3 miles. Likewise, Han's rate has to slow down. So this was his original rate right here. So he covered this distance where he was 3 miles from the parking lot in 3/4 of an hour. So now it's going to take him an hour, another 15 minutes to reach that same point. So he's going to be walking slower. So his rate is less slanted as well. And so he has to walk from 4 8/10 miles to 3 miles. That's 1 8/10 miles that he has to walk in 1 hour. So that's his rate, 1 8/10 miles per hour. So Han has to slow down from 2 4/10 miles per hour to 1 8/10 miles per hour. Now notice their combined rates, they're walking towards each other at a combined rate of 4 2/10 miles per hour, because that's the distance that they're apart. Remember, Jada walks this 6/10 of a mile first. Now they are 4 2/10 miles apart, and they have to cover that distance in 1 hour. Well, 2 4/10 miles per hour, Jada's rate, plus Han's rate of 1 8/10 miles per hour, that adds to the same 4 2/10 miles per hour. It has to make sense. So they're covering this distance in 1 hour. So here's both of them. This is what they were before. So they reached that distance of 3 miles from the parking lot sooner because they both are walking faster at this time. So this is a faster rate than this rate for Jada, and this is a faster rate. It's more slanted than this rate for Han. Now, what if we ask a similar question of, let's adjust their rates so they meet in an hour, but let's keep Han's or Jada's rate. So let's keep Jada's rate the same. So I'm going to put this arrow right here, and you can see that the intersection just slides up Jada's graph. So she's walking at the same rate. She's walking at a rate of 3 2/10 miles per hour. And so she's going to reach in 1 hour, she's going to walk that 3 2/10. But she is already 6/10 of a mile out. So that combined 6/10 plus 3 2/10 puts her 3 8/10 miles from the parking lot. Well, how long does it take Han to get to that same place? And how does he have to adjust his rate? Well, the distance that Han has to walk is 1 8/10 miles, because he's at 4 8/10 miles from the parking lot, and he has to get to a place that's 3 8/10 miles from the parking lot. That's 1 mile. So he has to walk 1 mile per hour. So he has to walk this 1 mile in this 1 hour. So he has to slow down from 2 4/10 miles per hour to 1 mile per hour. So how to adjust his rate? How? You realize that he has to walk 1 mile, and it has to take him an hour. So notice that they are still covering this distance between them of 4 2/10 miles in an hour. So these combined rates have to be 4 2/10 miles per hour. Well, Jada's walking at 3 2/10 miles per hour. Han is walking at 1 mile per hour towards Jada. So that combined rate is that 4 2/10 miles per hour. This was Han's original rate. So notice he's slowing down. His rate is becoming less slanted. So it's taking him a longer time to cover this distance of 1 mile. Before, he covered 1 mile in this amount of time, which looks like it's about 4/10 of a mile. And now it took him 4/10 of an hour. So now it took him 1 hour to cover that same mile. So he's walking much slower. Now, what if we went through the same exercise but kept Han at the same rate? So Han is going to stay at his same rate, but they're still going to meet after 1 hour. So where are they after 1 hour? So right here. So Han is going to be, he's walking at the same rate, and he's walking at a rate of 2 4/10 miles per hour. So he's going to be 2 4/10 miles closer to the parking lot. So he was at 4 8/10 miles. So you subtract the 2 4/10 miles. So this is 2 4/10 miles in 1 hour. So from right here, 4 8/10 minus 2 4/10, it's halfway actually, gets you to 2 4/10 miles in that 1 hour. So Jada has to reach that same point. So what does she have to do for her rate? So she has already walked the 6/10 of a mile. So now she has to walk another 1 8/10 miles to get out here to 2 4/10 miles. So she has to slow down. She's going to walk at a rate of 1 8/10 miles in that 1 hour. So she has to slow down. This was 3 2/10 miles per hour. And now she has to slow down. It's less slanted. So in that 1 hour, she's only going to walk 1 8/10 miles, which puts her at 2 4/10 miles from the parking lot. So she has to slow down. This is where she was at her previous rate after an hour. She was out here at 3 and she's walking at a rate of 3 2/10 miles per hour plus 6/10. So this would be 3 8/10 miles out here after 1 hour. But now she's slowing down. So she's only getting out 2 4/10 miles in that same hour. And notice that they are still 4 2/10 miles apart. So their combined rate, they're going to cover that 4 2/10 miles in 1 hour. So their combined rate has to be 4 2/10 miles per hour. Jada's walking at 1 8/10 miles per hour. Han is walking at 2 4/10 miles per hour. And so that adds to 4 2/10 miles per hour. Back here, it was 1 mile per hour plus 3 2/10 miles per hour for Jada, and that added to 4 2/10 miles per hour. So if you go back and forth between these graphs, it will start to make sense to you. There has to be a relationship between the coordinates of this point right here, which is 3/4 of an hour or 75/100ths of an hour, and 3 miles, because that is the point of intersection between the graph of both equations. So this line right here, which is the graph of Han's equation, and this line right here is the graph of Jada's equation. There has to be a relationship because that is the point of intersection between those two graphs. So what does that point mean? What are the coordinates? What do the coordinates of that point mean? So what's the relationship between these coordinates for both Jada's equation and Han's equation? So in Jada's case, this is her equation. So if you use 3/4 of an hour in Jada's equation, you're going to calculate that the distance that she walks from the parking lot when Han turns around is going to be 3 miles, because 3/4 of 3 2/10 32 divided by 4 is 8. 3 times 8 is 24, so this is 2 4/10. You're going to calculate a distance of 3 miles. Likewise, if you use that 3/4 of an hour in Han's equation, you are also going to calculate a distance of 3 miles. 24 divided by 4 is 6. 3 times 6 is 18. This is going to be a negative 1 8/10, plus the 4 8/10 calculates to 3 miles. So they are 3 miles from the parking lot when they have walked for 3/4 of an hour, both of them at the same time. So they're the same distance, 3 miles from the parking lot for the same time, 3/4 of an hour. So the coordinates are the same solution to both equations, 3/4 of an hour written either way, and 3 miles. So it's the same distance, it's the same time, it's the same solution. Now, do you see that Jada's slope is a positive slope because she's walking from the parking lot towards the lake. So she's walking in what in this situation we call a positive direction. Han is walking in a negative direction. He's walking back the other way. So his slope is a negative slope. But you use those two slopes and 3/4 of an hour, and you get a distance of 3 miles. So imagine that you start a stopwatch when they start walking towards each other. After Jada has walked her 6/10 of a mile, you start a stopwatch. When they meet, you stop that stopwatch. They will both have walked for the same amount of time, 3/4 of an hour. And it turns out that when they walk that 3/4 of an hour, the distance they're from the parking lot is 3 miles. So everything has to be the same. 3 miles, 3/4 of an hour, it's the same solution.